Okay, so this is about the quotient remainder theorem. So I've got a problem here to sort of motivate this. So a nice word problem. So I've got Molly's got 27 stickers and wants to give each of her 6 friends the same number of stickers, right? So how many stickers should Molly give to each friend? Okay, so typically that would be a division word problem, okay? This is actually the number of friends, the number of parts. This is partitive, not that that doesn't matter so much there. So I do 27 divided by 6. Okay, now, right, what you would think about is 6 times blank equals 27. Well, the answer to that, there is no whole number that goes there, right? And that's because 6 does not go in evenly into 27. Right? So, and hopefully we've seen this, but I know that 6 goes into 24, so I can write, again, 27 div 6 is 4, and there should be 3 stickers remainder, right? Okay, so I've got 4, she can get 4 stickers each friend, and she has 3 left over. So oftentimes questions like this pop up, and they have remainders on them. Okay, now the big thing about this is looking at, there is a very important theorem, which is why I want to cover this, called the Quotient Remainder Theorem. Okay, so this is the same terminology the book has. For 2 given, say, positive numbers, A, capital A, and K. I'm given these variables, so a little bit of algebra here. Okay. There are unique numbers Q and little r such that A equals K times Q plus R, with R could be as small as 0, and sorry, not Q, K, and up to K, but not equal to K. So it has to be smaller than K, but it could be 0. Okay, so we're going to see this throughout this course, and it's pretty important. So first of all, what I want to do is I want to just show what happens with an example like 27 divided by 6. And I should be pointing out, there's no division here. Why? Well, what do we have, right? So this is an alternative to A div K equals Q remainder R, right? So there's the quotient. And the remainder, right? And that's technically the divisor. Okay. It was div 6, right? Yeah, div 6. Okay. Now, one way to look at this is I've got this multiplication of K times Q. Okay, so we won't need to, we're trying to figure out what Q is and R is, right? And this is really stuff that comes out of division, but I'm going to explain it with just a model here. with this particular value about how this is all related. Okay, so what I'm going to do is I'm going to take an array model. Okay, K is my divider. K is 6. My number A is 27. So what I want to do, if I want to do blocks, I'm going to do blocks of 6 rows, and we'll just see how many of those fit in until I get 27. So here we go. Here's a block of 6. I'm going to do another block of 6. I'm going to do another block of 6. That's 18 right now. Another block of 6 is 24. Right? And how many are left? I've got 3. So there is 4. There is 6. So this is K. Here's my quotient, right? And R is 3. Is the remainder equals 27 blocks. Okay. Now, what this theorem is saying, the other key thing about this is it says there's unique numbers. So that basically means that if I do this, it doesn't matter what number, I'm talking about positive numbers here. If I've got A, the number of blocks, and 6, again the divisor, which would be sort of the number of rows if I'm building this out, I can always do this. Okay. And if you want to think about it, the other nice thing about this is right here, this is a very nice picture with this, is the remainder can be 0, meaning that I've got, say, like 6 times 4, I've filled in that whole thing and there's no more of these stray ones left over. Or R could be anywhere from 0 up to the number of rows, but not equal to the number of rows. So I could go, in this case, up to 5. So I could have either 0, 1, 2, 3, 4, 5 as a remainder, but not 6. And the reason I couldn't do 6 is as soon as I get to 6, I have a different quotient. This would go up to 5. And then R would be 0. So this is kind of a nice picture. All right. Now this theorem basically just says this is always true. I'm not going to prove it. We're going to do some proofs of things from time to time. I'm not going to prove this, but this is quite nice, and we're going to see this again and again. One of the very practical things that we're going to see this with is in long division, in terms of when you're doing long division and you come up with basically there's some checking steps in there, and we'll go through those. So when you're going through long division, there's checking steps, and the checking step is that situation there. So we've got that. All right. Now there's one other thing I'm going to talk about related to this, and that is division by 0. All right, so somebody give me their favorite positive number out there. Okay, I heard 4. Okay, good. So I'm going to do a few things here. I'm going to say 0 divided by 4 equals something. 4 divided by 0 equals something. And let's also do 0 divided by 0 is something. Okay, these are always mixed up. I wouldn't say always mixed up. They're often mixed up. So I want to just talk about them. So here, what do I have here? This is 4 times blank equals 0. And the answer to that is definitely 0. What is this? This is 0 times blank equals 4. So what number can I multiply by 0 to get 4? Okay. This answer does not exist. Okay. Basically, you might think of I've got in my head I can't divide by 0. This 0 divided by 0 is, I can write like that. Any number goes here. Okay. And because of that, we like to have, in mathematics, things that have a single answer. That's what's called uniqueness, right? And because of this, we usually also say does not exist because of this. Okay, so often you'll run into these situations, and you kind of have to keep this stuff straight. One of the ways I always like to do this, because people like pizza, going through everything like this. If 4 people are going to share 0 pizzas, how much pizza does everybody get? Well, that's the answer. 0. So 0 divided by 4 is 0. I have 0 pizzas. I have 4 people. How much pizza does everybody get? 0. Okay. This case, I have 4 pizzas and 0 people. How much pizza does everybody get? I don't know. There's no people. It doesn't make any sense. Okay. Again, 0 pizzas, 0 people. The question just doesn't make any sense. Okay. The first one makes sense. No pizza, 4 people. Everybody gets 0 pizza. All right. So that wraps up the quotient remainder theorem.